mathematics, as well as his fondest privilege is to explain the humanity of mathematics, to illustrate its greatness, beauty, and dignity,
and to describe how the incessant efforts and accumulated genius of many generations have built up the magnificent monument.
Hi, I'm Lady.
Hey everybody, I'm Oreo! The creation of calculus is credited to two men who individually developed its foundations. Even though they were both very important parts of this creation, they thought of concepts in very different ways.
While Newton thought of variables changing over time, Leibniz considered the x and y variables as ranging sequences of infinitely close values. He also introduced dx and dy as following values of these sequences. He knew dy dx gives tangents and is not a defining property. All the while, n used x prime and y prime, which were limited velocities, to calculate the tangent.
And of course, neither of them thought in terms of function, but in terms of graphs. For Newton, calculus was geometrical, and for Leibniz, it was analytical.
We got it from here
We'll tell you guys all about how we created the calculus.
that you use today.
Hello, my name is Gottfried, and I'm a German mathematician born in 1646, but sadly died in 1716. I developed a notation for integral and differential calculus, though I never thought of the derivative as a limit. My philosophy is important, and I also created the calculating machine. I am known as one of the three great 17th century rationalists, and my work consisted of modern logic and analytic philosophy. Like many great thinkers, I was a child prodigy, and I was an amazing contributor to many different fields. Between my work and my day job, I still found time for mathematics. I was the first to utilize mathematical notations to denote geometric concepts derived from a curve. I was part of the Royal Society, and, well, I was very aware that Newton was working on calculus as well. I independently created a very similar theorem of calculus, and then independently created a complete theorem of integral and differential calculus. I was very open in sharing my work to the public, but they gave Newton the title as first discoverer, even though he hasn't shared anything to the public until 1693. I knew that the Royal Society favored Newton over me, and how dare they accuse me of plagiarism? I'll never forgive them for that. Nope. But, ironically, you guys are using my writing of calculus instead of Newton's old, clumsy writing of calculus, you know. I rediscovered the method of arranging linear equations in an array now called matrix. And I paved the way for later work on matrices and linear algebra. Later on, I worked on an invention of a practical calculating machine and made it capable to multiply, divide, and even extract roots. I enunciated in my working drafts the principal properties that you guys now call conjunction, disjunction, negation, identity, set inclusion, and empty sets. In other words, I'm better than Newton.
Hello, I'm Isaac Newton, and I was the greatest mathematician of my generation. I was born in 1643, and I died in 1727. I laid the foundation for differential and integral calculus. My work on optics and gravitation make me one of the greatest scientists the world has ever known. During the 17th century in England, during the British expansion, Oxford was creating great mathematicians and scientists. But I was definitely the greatest. I was a physicist, a mathematician, an astronomer, a natural philosopher, an alchemist, and theologian. And I'm considered to be one of the greatest men in history. Are you one of the best men in history? I don't think so. Still young, during the Great Plague of 1665, I developed a revolutionary approach to mathematics. Calculus, no biggie. I also developed a new theory of light, discovered and quantified gravitation all around the same time. I had some help from a couple of my buddies, but I did most of the work. My biggest problem was that even though it was easy to calculate the average slopes of a curve, the slope of a curve is always changing, and there was no way for me to calculate the slope of the curve for it to be exact. With my great skills, I observed that the slope of a particular point can be approximated by taking the average slope. What you know today is rise over run. Also, I can say that as a segment of the curve approaches 0, the calculation of the slope approaches closer and closer to the exact slope at that point. So basically me and the other guy we, mostly me, calculated a derivative of the function f prime of x, which gives a slope at any point of a function f of x. I called it the method of fluxations, but somebody decided that a better name was differentiation. For example, the derivative of a straight line, f of x equals 4x, is 4, and the derivative of a squared function, f of x equals x squared, is 2x. Of a cubic function, such as x third, is 3x squared. Method of fluence, or as you may call it, integration, and differentiation are a part of my fundamental theorem of calculus. My theorem says that differentiation and integration are inverse operations, meaning that if the first function is integrated and then differentiated, the original function is restored. The integral of a curve can be thought as the formula of calculating the area bounded by the curve and the x-axis between two defined boundaries. For example, on a graph of velocity against time, the area under the curve would represent the distance traveled. At the time, I decided not to publish my revolutionary mathematics straight away because society was not very nice and I didn't want to deal with it. But I did share it with my friends, plus I had other hobbies such as philosophy, alchemy, and my work at the Royal Mint. But in 1684, this guy named Leibniz decided to publish his very own independent version of the theory, but I only decided to publish in 1693. And the Royal Society decided to give me the credit for the first discovery of calculus and him the credit for first publication. I mean, I guess it's fair, but he never got over it.
Thank you guys for watching.
And that's how the history of calculus goes.